14.1 Limits. So what exactly is a limit? A limit is the value of a function as x approaches c. And we can write this as LIM, which stands for limit. And below that we write as x approaches c. And c stands for constant in this case. So what exactly is a limit? Let me show you an example problem and we can figure this out together. So if f of x is equal to sine x divided by x, what is the limit of f of x as x approaches 0? So to find this, we have two ways to find this. First, we can pull up our calculator here, and we want to put sine of x divided by x into our graphing calculator. So if I click y equals, we can see I already have sine of x divided by x inserted into my calculator. Now we can click graph. And this is what you should see on your calculator. Now we want to know what sine of x divided by x is when it approaches 0. Not what it is at 0, what it is approaching 0. And there's two ways we could solve this. The first thing we could do is click the trace button right here, and we can see at x equals 0, y is equal to nothing, so it is undefined. And to find the limit, you want to see what x is to the left of 0 and to the right of 0. So you simply click the left button here. We can see left of 0 is approximately 0.99, or to the right of 0, it is approximately 0.99. Now, the more accurate way of doing this is to click second window, which is table set, and you get to this screen. So your table start, you're trying to find when x approaches 0. So you want your table to start at 0. And then table 1 right here is the x amount. So you want this number to be really small because you're looking at right before 0 and right after 0. So I have 0.001, and this is just a good number to have when you're looking at your tables. So from here, you click second again, and you click graph or table. And this pulls up this screen. Now from here, move up a little bit. That way you can see left and right of 0. We can see at 0, it is error or undefined, like we saw when we did the trace feature. But in this screen, we can see left of 0, negative 0.001, x is equal to y is equal to 1. And right of 0 at 0.001, we have 1 again. So this is showing us here that when we put 0, and this shows us that the limit of f of x as x approaches 0 is 1. And we can also write this as the limit of sine of x divided by x as x approaches 0 is equal to 1. That is how you find the limit of a function and what is a limit. Example 2. Find the limit as x approaches 4 of f of x. F the function is given by the following rule. F of x equals 0 if x is an integer, and f of x equals 1 if x is not an integer. This type of problem is much easier to do by hand than it is by calculator, so we will be doing it by hand today. So we need to find the limit as x approaches 4 are constant for f of x. With limits, you want to look right before and right after our constant, which is 4. So we're looking at 3.99. 3.99 is not an integer, therefore the answer is 1, which is why we have 1 here. And right after our constant 4, we have 4.01. That is also not an integer, so we have 1 as our answer. We can also see this by our graph. We have the line going straight across 1 because 3.99, 3.98, 3.97, all of those decimal places are not an integer. But when we get to 1 and -1, those numbers are integers, so we have holes on our graph there. Therefore, the answer to this problem is the limit of f of x as x approaches 4 is equal to 1. Example 3. F of x equals sine squared pi x minus cosine pi x. Find f of 0.5 or 1/2 in the limit as x approaches 1/2 of f of x. The first thing you should do, plug this in your calculator. I already have this entered in, and then click graph. Your equation should look something like this. And the first step is find f of 0.5 or 1/2. Simply click trace, type in 0.5 down below, and click enter. The cursor should bring you to x equals 0.5 and the y. We have here y equals 1. So f of 0.5 is equal to 1. Now, to find the limit of f of x as x approaches 1/2, you want to go to second window, type in 0.5 for table start, and have your table 1 be a small number such as 0.001. From here, go second graph or table, move up a few spaces and go back down. We can see here, right above 0.5 at 0.499, our answer is 0.9968, or basically 1. And if you go right above 0.5 at 0.501, we can see the answer is 1.0031, which is basically 1. Neither of these numbers here, 0.9968 and 1.0031, are 1, but they're so small that they're basically the same number as 1. So we can write our limit as this. The limit as x approaches 0.5 for f of x is equal to 1, or since both of these equations, f of 0.5 and the limit as x approaches 0.5 of f of x, are both equal to 1, we can write them like this. The limit of f of x as x approaches 0.5 is equal to 1, which is equal to f of 0.5. Non-existence of limits. We need to find the limit as x approaches 0 of 1 divided by x squared. So the first thing we should do, once again, come to y equals, plug your equation into the calculator, just like I have here. From here, should come the graph. You should have an equation that looks something like this, a volcano shape, I would say. From here, you want to go to your table set and have your table start at 0. That is our constant. And have your table 1 be a small number like we've had in the past. From here, come the second table, once again, move up a little bit, and then move back down to 0. So we can see here at 0, which is what we're trying to find, the limit of 0, we have an error. Therefore, our graph is never going to hit 0. It's undefined at 0. Now, the limit, there is no limit of this equation. And we can see because as the equation gets closer to 0, the numbers get bigger. And as they get farther away from 0, y gets smaller. We can see this in the graph. As the graph approaches 0, we slowly get bigger and bigger y values. And as we go away from a 0, we get smaller y values. We can see this in the graph as well. We can see that right above 0, we have a pretty big number, and right below that, it gets smaller and smaller and smaller, and that goes for both sides of the 0, above and below 0. Therefore, the limit as x approaches 0 of 1 divided by x squared does not exist. A function that approaches two values. We need to find the limit as x approaches 0 of the absolute value of x divided by x. First thing we should do, plug it in our calculator just like this and graph it. We get this absolute value function here. Next, second window, have your table start at 0 and your table 1 be a small number, and then come to the second table just like we've done before and set up your table so you can see both sides of the constant 0 in this case. We can see that to the left of 0 we have -1 as it approaches 0, and to the right of 0 we have +1 as it approaches 0. We can see this in the graph as well. As the graph approaches 0 from the left side, we have -1, and as it approaches from the right side, we have +1. To be a limit, both sides of the equation need to have the same number as they approach 0. This limit does not exist because we have -1 from the left side and +1 from the right side. So the limit as x approaches 0 for the absolute value of x divided by x does not exist. An oscillating function. We need to find the limit as x approaches 0 for sine pi x. So like we've done with all the other equations, come to y equals and plug your equation in. Then come the graph, and you should get a graph that looks something like this. You want to come to the second window, have your table start at 0, that is the constant. Then have your table 1 be a small number such as 0.001. From here we can come to the second graph table. We can look at our table from here. Move up a little bit and move down. So we can see here that our function does not really approach one particular value. We have 0 here, -0.866, moves back down to 0, and the numbers keep fluctuating and eventually get back to 0. And if you go look below 0 to the negatives, we can see it does the same thing. Because the limit of sine pi divided by x does not approach one particular value, the limit as x approaches 0 for sine pi divided by x does not exist.